Welcome to Grade 9, Unit 6 Cyber class on Statistics and Probability. This is Module 6.2 on Probability. The objectives for this module are to define probability, to understand facts and basic principles about probability, to understand theoretical and experimental probability, and to be able to work out probabilities for two events. What is the probability of it raining tomorrow? What is the likelihood that I will pass my test? What is the chance of us winning the football match this afternoon? Am I certain to get to school on time if I catch the bus? These statements are all connected because they're all to do with probability. And these words here, probability, likelihood, chance, and certain, are all words that are used in probability. We represent probability on a scale like this. In the middle is an even chance, or a probability of a half. This is where it's equally likely that the event does happen or doesn't happen. On the left is impossible, or a probability of 0, which means that the event definitely will not happen. And on the right is certain, or a probability of 1, which means that the event will definitely happen. The probability of an event happening will always lie somewhere on this scale between 0 and 1. An experiment is the process by which we obtain an outcome. An event is an outcome from an experiment. And a random experiment is one where there is uncertainty over which event may occur. Examples of random experiments include rolling a dice 3 times, tossing a coin once, picking 2 cards from a pack of 52 playing cards, recording the number of cars that pass the school gate in a 5-minute period, or spinning a spinner. They are all experiments because they all have different outcomes. For example, different numbers that are rolled on the dice, heads or tails, different things on the cards, different numbers of cars, and a different result on the spinner. And they are all random experiments because we're not sure what the outcome is going to be. For any event E, 0 is less than or equal to the probability of E, which is less than or equal to 1. Theoretical probability. Here's an example of an experiment, rolling a fair dice and seeing what number is rolled. S is called the sample space, which is the set of all possible outcomes from the experiment. In this case, we're rolling a fair dice, so the different possible outcomes would be the different numbers that we get on the dice, 1, 2, 3, 4, 5, or 6. N of S is the size of the sample space. In this case, it's 6, because there are 6 different numbers in the set. Let the event E be defined as the number 6. This is one of the outcomes from the experiment. N of E is the number of ways that the event can occur. In this case, it's just 1, because there's only one way to roll a 6. The probability of this event happening is 1/6. Now let the event E be defined as an odd number. The number of ways that this can happen is 3, because we could either roll a 1, a 3, or a 5. So the probability of this event happening is 3 out of 6, or a half. We can come up with a formula for theoretical probability. The theoretical probability of an event E is written as P of E and is equal to N of E over N of S, where N of E is the number of ways that the event A can occur, and N of S is the total number of possible outcomes. N of E is the size of the event space, and N of S is the size of the sample space. Here's an example. A fair 20-sided dice with faces numbered 1 to 20 is rolled. The event E is defined as the number is a multiple of 4. Determine the probability of E. The dice is rolled 100 times. How many times would you expect a multiple of 4? Here's the solution. The probability of E is equal to N of E over N of S. N of E is the size of the event space, so the number of ways that the event can occur. These are the ways of getting a multiple of 4. We could get 4, 8, 12, 16 or 20. So the size of the event space is 5. The size of the sample space is 20 because there are 20 different options. So the probability of E equals 5 over 20 or a quarter. For B, we know that a multiple of 4 occurs a quarter of the time. So out of 100 times, we expect it to be a multiple of 4 a quarter of 100 times, and a quarter times 100 is 25. Here's another example. A bag contains 40 discs numbered 1 to 40. A disc is selected at random. Find the probability that the number on the disc A is an even number and B has the digit 1 in it. Here's the solution. The probability of E is equal to the size of the event space divided by the size of the sample space. In this case, the even numbers are 2, 4, 6, 8, 10, 12 and so on up to 40. There are 20 of them. And the total sample space is all the numbers from 1 to 40, so there are 40 of them. So the probability of the event happening is 20 out of 40, or a half. For B, the number of discs that have the digit 1 in them are 1, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21 and 31. There are 13 of these, so the probability is 13 out of 40. Experimental probability. You can use an experiment to estimate probabilities. For example, the colours of cars passing the school gate one morning are given in this table. Red, black, yellow, green, blue, grey, other. 45, 16, 2, 14, 17, 23 and 21, and in total there are 138 cars. Estimate the probability that the next car to pass the school gates will be red. Well, in this case there are 45 red cars out of a total of 138, so the probability of red is equal to 45 over 138. This is only an estimate because this was obtained from an experiment. B. The next morning 350 cars passed the school gates. Estimate the number of red cars that morning. Well, we know that the cars are red on average 45 out of 138 of the time. So 45 out of 138 times 350 gives us about 114 red cars. Tree diagrams are useful for problems where more than one event occurs. For example, a coin and a dice are tossed simultaneously. What is the probability of getting a tail and a prime number? We can draw a diagram for this. Start with the coin. It's either a head or a tail. We then put the dice after the coin. So if the coin was a head, then we look at the options for the dice, which were 1, 2, 3, 4, 5 and 6. And if the coin was a tail, we also then look at the options for the dice, which again is 1, 2, 3, 4, 5 or 6. The probability of an event happening is the size of the event space divided by the size of the sample space. So if we want to get a tail and a prime number, then it could be any of these. It has to be a tail first, and then a 2, 3 or a 5. So there are 3 ways to do it, out of a total of 12 different outcomes. So the probability is 3 out of 12, which is a quarter. Here's another example. A coin is tossed 3 times. What is the probability of getting at least one head? Again, let's draw a tree diagram. Here's the first coin. It's either a head or a tail. Then, here's the second coin. It's either a head or a tail here, and then either a head or a tail here. And then here's the third coin. Head or tail, head or tail, head or tail, head or tail. We want to get at least one head, which means that we could go down any of these routes except for this last one, tail, tail, tail. So there are 1, 2, 3, 4, 5, 6, 7 possible routes, out of a total of 8 altogether. So the probability is 7 out of 8. Probability using a table. Here's another example. 2 dice are tossed simultaneously. What is the probability of getting a sum of 9? We could use a tree, but in this case it's more efficient to use a table, because then we can see the direct relationship between the first dice and the second dice. We put the first dice along the top and the second dice down the side, and then inside the table we can see the combinations between the first dice and the second dice. And we want to find all the ways of getting a sum of 9. So that would be this one here, a 3 and a 6, or this one, a 4 and a 5, or a 5 and a 4, or a 6 and a 3. And that's all the different options. The probability is the size of the event space divided by the size of the sample space. So in this case it's 4 out of the total number of combinations, which is 36. And this simplifies to 1 out of 9. To summarize, statistics is the science concerned with developing and studying methods for collecting, analyzing, interpreting and presenting empirical data. A population is the complete collection of individuals, objects or measurements that are being studied. A sample is a part or subset of a population. Data is information about individuals in a population. Qualitative data is the data in which the classification of objects is based on attributes and properties. Quantitative data is the type of data which can be measured and expressed numerically. Primary data is data that is collected from first-hand sources, e.g. with surveys, interviews or experiments. Secondary data is data gathered from studies, surveys or experiments that have been run by other people or for other research. The mean is the total amount shared out equally between all the values. It can be calculated using this formula: x bar is equal to the sum of all the x values over n, or the sum of the x values over the sum of the frequencies, or, in the case of a frequency table, the sum of the data values multiplied by the frequencies divided by the total frequency. The mode is the most frequently occurring value in the dataset. The median is the middle value of an ordered dataset. The range is the difference between the maximum and the minimum data value. The variance is the mean of the squares of the differences of each value from the arithmetic mean. It can be calculated using this formula: delta squared is equal to the squared differences of each value from the mean, all added together and divided by n. Or, delta squared equals the sum of x minus x bar squared, all over the sum of the frequencies. And in the case of a frequency table, it's the sum of the frequencies multiplied by x minus x bar squared, all divided by the total frequency. The standard deviation, delta, is the square root of the variance. Standard deviation is always non-negative. If we add a constant c to a list of numbers, the mean, median and mode increase by c. The range, standard deviation and variance stay the same. If we multiply a list by a constant c, the mean, median and mode are multiplied by c. The range and standard deviation are multiplied by the absolute value of c, and the variance is multiplied by c squared. To summarize, probability is the measure of the likelihood that an event will occur. The set of all possible outcomes of an experiment is called the sample space. The probability of an event happening is the number of ways an outcome can happen divided by the total number of possible outcomes. If an event is certain to happen, its probability is 1. If an event is impossible to happen, its probability is 0. Review questions part 1. The number of faulty products returned to an electrical goods store over a 21-day period is given by this list of data. Construct a frequency table. Construct a bar chart. Pause the video whilst you have a go. Here's the answer. This is the frequency table. It shows the different values and shows the frequencies here. And the bar chart should look like this. The number of faulty products is here and the frequency is here, and each bar shows how many times that many products were returned. Part 2. Amanda collected 20 leaves and wrote down their lengths. You can see the lengths here. Construct a frequency distribution. Find the modal length, work out the median, and work out the mean. Pause the video whilst you have a go. Here's the answer. For the frequency distribution, we want to create a frequency table like this, that has the lengths here and the frequencies here. The modal length is 5 centimeters because that occurs 6 times, so that's the most common. For the median, there are 20 leaves altogether, so we want to do 20 plus 1 over 2, which is 10.5, so we want to find the value that's between the 10th and the 11th point. Here we've got 1 point, then another 1, then another 4, which takes us up to 6. So the 10th and the 11th data points are both within this set here, so they're both 5, so the median is 5. For the mean, we need to find out the lengths multiplied by the frequencies, add them all up to get 106, and divide by the total frequency. So 106 divided by 20, which is 5.3 centimeters. Part 3. The annual salaries of 10 office workers are given by this data here. Find the mean, median, range and modal salaries of this group. Pause the video whilst you have a go. Here are the answers. First of all, for the mean, we add up all of these values and divide by 10, which gives us 29,300. For the median, there are 10 values, so we do 10 plus 1 over 2, which is 5.5, so we want to be between the 5th and the 6th value. The 5th value is 23,000, and the 6th value is 24,000, so the average of these two is 23,500. The range is equal to the largest salary, 46,000, minus the smallest salary, 23,000, which is 23,000. And the mode is the most common salary, which is 23,000, because that occurs 1, 2, 3, 4, 5 times. Part 4. Find x if 5, 9, 11, 12, 13, 14, 17 and x have a mean of 12. Find a if 3, 0, A, 4A, 6A and 3 have a mean of 4. Pause the video whilst you work them out. Here are the answers. For number 1, we want to add together all of these points, divide by 8 and get an answer of 12. So x must be 15. For number 2, we want to add together all these values, divide by 9 and get an answer of 4. So a must be 5. Part 5. A sample of 10 measurements has a mean of 15.7 and a sample of 20 measurements has a mean of 14.3. Find the mean of all 30 measurements. The mean and median of a set of 9 measurements are both 12. 7 of the measurements are 7, 9, 11, 13, 14, 17 and 19. Find the other 2 measurements. Pause the video whilst you work them out. Here are the answers. For part A, we want to find the sum of the original 10 and the sum of the next 20, and add those together and divide by 30. So we get 157 plus 286 divided by 30, which is 14.77. For part B, the mean is 90 plus A plus B over 9, which equals 12, which means that A plus B must be 18. And we are also told that the median is 12, so the fifth number must be 12, so B equals 12 and A equals 6. Part 6. The following frequency table records the number of phone calls made in a day by 50 20-year-olds. For this data, find the mean, mode, and median. Pause the video whilst you work them out. Here are the answers. The mean is 2.96, the mode is 2, and the median is 2. Part 7. The frequency column graph gives the value of donations for the Heart Foundation collected in a particular street. Find the mean, mode, and median. Pause the video whilst you work them out. Here are the answers. The mean is 2.9 beer, the mode is 2 beer, and the median is 2 beer. Part 8. A dataset has the following measures of centre and spread. Determine the new value of each of these measures if every member of the dataset is increased by 2. Pause the video whilst you decide. Here's the answer. The median, mode and mean all increased by 2, and the range and standard deviation stay the same. Part 9. A dataset has the following measures of centre and spread. Determine the new value of each of these measures if every member of the set is doubled. Pause the video whilst you decide. Here's the answer. The median, mode, mean, range and standard deviation are all doubled. Part 10. The number of points scored by Henok and Helen in the last 8 basketball matches are tabulated below. Find the standard deviation of the number of points scored by each player. Which of the two players is more consistent? Pause the video whilst you work it out. Here's the answer. To work this out, we need to add some more rows to the table. Now, if we have a look at the points that Henok scored and find the sum of all of these points, which is 200, and divide it by 8, we get the mean of 25. And the same for Helen, we get a mean of 30.5. Now that we've got these means, we can find the squared differences between the data points and the means, which is in this row here, and add all of these up to get 198, and divide by 8 to get a variance of 24.75, and the same for Helen here, a variance of 157.75. The standard deviation is equal to the square root of the variance. So Henok's standard deviation is 4.97 and Helen's standard deviation is 12.6. Which of the two players is more consistent is Henok, because he has a smaller standard deviation, which means he has a smaller spread and his values are closer together. Part 11. If the variance of A, B, C and D is K, then what is the variance of A plus C, B plus C, 2C and D plus C? The standard deviation of A plus C, B plus C, 2C and D plus C? The variance of AC, BC, C squared and DC? And the standard deviation of AC, BC, C squared and DC? Pause the video whilst you decide. Here are the answers. For part A and B, we've added a constant to all the data values, so the variance and standard deviation are the same as the original set. So the variance is K, and the standard deviation is the square root of K. For C and D, we've multiplied all the values by a constant, so this time the variance is multiplied by that constant squared, and the standard deviation is multiplied by the absolute value of that constant, so it becomes the absolute value of C times the square root of K. This is the end of 6.1. Review questions part 1. What is the sample space of a fair 6-sided dice? If a 6-sided fair dice is rolled and then a quarter is flipped, what is the probability of getting an even number and a tail? Pause the video whilst you work them out. Here are the answers. Number 1, the sample space is 1, 2, 3, 4, 5, 6. Number 2, the probability is a quarter. Part 2. A spinner has 8 sections numbered 1, 2, 3, 4, 5, 6, 7 and 8. Find the probability of the spinner landing on a 6, on an even number, on a number less than 7, on a square number, on a prime number, on a 2-digit number, on a single-digit number. Pause the video whilst you work them out. Here are the answers. On a 6 is an eighth, on an even number is a half, a number less than 7 is 3/4, a square number is a quarter, a prime number is 0.5 or a half, a 2-digit number is impossible, so the probability is 0, and a single-digit number is certain, so the probability is 1. Part 3. A fair 6-sided dice numbered 1 to 6 and a fair 4-sided object numbered 1 to 4 are both tossed at the same time. What is the probability that you get a 4 and a 1, a sum of 7, a sum of more than 7? Pause the video whilst you decide. Here are the answers. Part I is a 12th. For part II, the best thing to do is to draw a diagram so that you can see the combinations between the two objects. This shows us that a sum of 7 can occur in 4 different ways, so the probability is 4 out of 24, or 1/6. And part III can occur in 6 different ways, so the probability is 6 out of 24, or a quarter. Part 4. In a survey, 100 students were asked, do you prefer to watch television or play sport? Of the 46 boys in the survey, 33 said that they would choose sport, while 29 girls made this choice. Find the probability that a student selected at random prefers to watch television. A student prefers to watch television given that the student is a boy. Pause the video whilst you work them out. Here are the answers. I is 38 out of 100 and II is 13 out of 46. Part 5. A running club has 160 members. 74 of the club members are female. 58 of the female members are over 18. 21 of the male club members are under 18. Find the probability that a member of the club chosen at random is under 18. Pause the video whilst you work it out. Here's the answer. The number of females that are under 18 is 74 minus 58, which is 16. The number of males which are under 18 is 21. So the total number of members that are under 18 is 37, and the probability is 37 over 160. This is the end of Module 6.2.